Okay, so this is the explanation of example 2b, and if you're watching this, hopefully you've seen the explanation of the first part, Algebraic Proofs 1. But if you haven't, then this could be a standalone example of justifying each step as we do something. And so what we're going to do here is we are going to take the time to find out what we're doing, and we're going to justify it. So let's see. If I know that the whole angle is equal to 8x, and this is going to be degrees, and this is going to be degrees, what I can say is the measure of angle ABD plus the measure of angle CBD is equal to the measure of angle ABC. Okay? The justification for that step is going to look like this. That's going to be angle addition postulate. Because I know that if I'm adding two angles together that are adjacent to one another, then they're equal to the sum is equal to the larger angle. And so my next step is going to be to say, okay, well, then that means that 3x plus 5 plus 6x minus 16 is equal to 8x. The justification for that step would be saying I've substituted the values. Okay? Now, when I go down to the next step, I'm going to be taking pieces that go together and putting them together. So I've got 9x minus 11 is equal to 8x. That's going to be simplification. Simplifying my life there. And now I'm just going to solve. And so what I can do is I can say I'm going to subtract 9x from both sides. And so what I've got here is minus 11 is equal to minus x. Okay? This right here, this step that I did, is called the subtraction property of equality. Got a little carried away with the marker there. So we'll call that the subtraction property of equality. And we're going to call this step simplification. All right, and so now what I'm going to do is I'm going to divide both sides by -1 because I need my x to be positive. And when I divide both sides by the same number, that's called the division property of equality. Okay, so what I end up with is 11 equals x, and I can switch those around to say x is equal to 11, and the reason why I can switch them around is because I can use the symmetric property of equality. So the symmetric property of equality says I can switch them around. So that's my answer. X is equal to 11, and I could substitute it in and find out what was going on. For the next part of this algebraic proof, we're going to look at some properties of congruence. And when we're talking about congruence, this is what we're talking about. It's written as congruent. So that's the shorthand form of what we can do. That's the symbol for congruent. It roughly means it's equal, but it's the same size. So that's why it's got the little squiggly over it. It's a little bit different than equal. It's the same as saying the shapes are the same size. And so for the reflexive property, what the reflexive property says is, if we're looking in terms of figures, so we're going to say for a given figure, figure A, which could be a segment, angle, etc. Figure A is congruent to figure A. Okay? It's like looking in the mirror. A is congruent to A. They're the same size, same shape. So A is congruent to A. Symmetric property looks like this. For a figure A, if figure A is congruent to figure B, then figure B is congruent to figure A. So these things, you can switch them. You switch the order. A is congruent to B. B is congruent to A. Okay? Transitive property looks like this. If figure A is congruent to figure B, and figure B is congruent to figure C, then we can say figure A is congruent to figure C. It looks like this. We've basically got a middleman here. So A is congruent to B, but B is congruent to C. So what the transitive property allows us to do is say, let's forget about this part. We will just say figure A is congruent to figure C. Okay? Those are the properties. And so when we go to look at these things, what we're saying is let's identify what we are doing. Okay, so for the first one, if the measure of angle 1 is equal to the measure of angle 1, the distinction we're going to make here is it's like a mirror, same on both sides. So it's going to be the reflexive property of equality. Reflexive property of equality. Okay? Because the equal sign is the equal sign. Okay? Now, we have xy and xy, vw, vw. Notice the colors have switched places. Okay? So they've switched places here. So what that tells me is that we're using a congruent sign, so it's going to be of congruence. Notice, congruent sign, okay? And if they switch places, that tells me symmetric property of congruence, okay? Now, same as letter A. Same thing on both sides. So it's going to be reflexive property of, and this time it's going to be congruence because we have a congruent sign. Notice how that works, okay? At the bottom, we have 1, 2, 3, 3. But 2 and 3 are going together. So what we've done is we've said we're just going to use 1 and 3. So look what happens. We're cutting out this middleman. So this tells me it's transitive property of congruence. Okay? Transitive property of congruence. We're labeling. Why are we doing what we're doing? Why are we able to say these things? That's the gist of proofs. Okay? If you have any questions, be sure to go back, rewatch, write your questions in the margin, and email me, message me, or talk to me in class. We will see you